everyone, welcome back to my channel. In this video, we will discuss some interview questions which are asked in data science interviews. ये 10 मोस्ट कॉमन क्वेश्चंस हैं जो हर डेटा साइंस के इंटरव्यूज में पूछे जाते हैं. तो लेट्स डिस्कस these questions. So the first most common question is explain a data science project you have worked on. आपको एक अपना डेटा साइंस प्रोजेक्ट एक्सप्लेन करना है जिस पे आपने काम करा है. इसको एक्सप्लेन करने के लिए आपको स्टार मेथड यूज करना है. स्टार है सिचुएशन, टास्क, एक्शन, रिजल्ट. सिचुएशन होता है व्हाट वाज द कॉन्टेक्स्ट. सपोज आपने एक सेल्स फोरकास्टिंग प्रोजेक्ट पे काम किया है, तो आप इस पे बोल सकते हो आई वर्कड ऑन अ सेल्स फोरकास्टिंग प्रोजेक्ट फॉर एन ई कॉमर्स कंपनी. The company faced challenges in predicting monthly sales for different products, leading to overstocking or stockouts. This affected their revenue and increased inventory cost. They needed an accurate forecasting model to optimize inventory management and demand planning. आपको इसमें डिटेल्स देना है कि क्या प्रॉब्लम था अ, उस ऑर्गेनाइजेशन में और उनको इसकी रिक्वायरमेंट क्यों थी. ये हो गया एस विच इज सिचुएशन. देन कम्स टी विच इज टास्क. टास्क इज व्हाट वाज योर रिस्पॉन्सिबिलिटी इन दिस प्रोजेक्ट. इसमें आपको एक्सप्लेन करना है कि आपका क्या रिस्पॉन्सिबिलिटी था, आपने क्या करा है इस प्रोजेक्ट के लिए. इसको आप ऐसे आंसर कर सकते हो. माई रिस्पॉन्सिबिलिटी वॉज टू डेवलप a machine learning model that could accurately predict future sales based on historical data. This involved collecting and pre-processing sales, promotions, and seasonal data, performing EDA to identify trends, implementing ML and time series forecasting models, and finally optimizing the model for higher accuracy and lower error rates. ST के बाद आता है A. A फॉर एक्शन. एक्शन में है व्हाट स्टेप्स डिड यू टेक. तो इसमें आपको पूरा एक्सप्लेन करना होगा. प्री प्रोसेसिंग, फिर ईडीए, उसके बाद मॉडल सिलेक्शन का प्रोसेस, मॉडल ट्रेनिंग का प्रोसेस, एंड मॉडल इवैल्यूएशन, एंड फाइनली रिजल्ट. R in the STAR, R stand for result. So what was the outcome? तो आपको इसमें बताना होगा कि आपका मॉडल से क्या हेल्प हुआ. फॉर एग्जाम्पल यू कैन से लाइक 20% improvement in demand planning accuracy, reducing stock mismanagement, inventory cost reduced by this percentage, help the company to optimize marketing campaigns. और इसमें आपको टूल्स कौन से यूज हुए और इसका इम्पैक्ट क्या था आपके प्रोजेक्ट का, ये भी इंक्लूड करना है. टूल्स यूज्ड में आप मोस्टली पाइथन, सीक्वेल, सीबॉर्न, मैटप्लॉटलिब, पावर बीआई और टैबलू समथिंग फॉर विजुअलाइजेशन. तो ये सब आपको एक्सप्लेन करना है. और इम्पैक्ट में आप ऐसे बता सकते हो जैसे इम्प्रूव्ड सेल्स प्रिडिक्शन, ऑप्टिमाइज इन्वेंट्री मैनेजमेंट. तो ये इम्पैक्ट में हो जाएगा. तो आपको स्टार अप्रोच यूज करके इस क्वेश्चन का आंसर देना है. So the next question is, what's the difference between supervised and unsupervised learning? ये भी एक बहुत ही कॉमन क्वेश्चन है जो हर इंटरव्यू में पूछा ही जाता है. When you are answering this question, you should give a clear, concise, and structured answer to differentiate supervised and unsupervised learning. Also provide examples and use cases. For definition अगर हम देखें supervised learning का, तो supervised learning is a type of machine learning where the model is trained on labeled data. इसमें जो हमारा इनपुट होता है वो लेबल्ड होता है. Data is paired with correct output, and the model learns to map input to output based on this training. And if we define unsupervised learning, it is a type of machine learning where the model is trained on unlabeled data. That is, the only input data is provided, and the model finds patterns and relationships on its own. अगर हम इसमें की डिफरेंसेस देखें बिटवीन सुपरवाइज्ड एंड अनसुपरवाइज्ड लर्निंग, तो वो होगा फर्स्ट डेटा टाइप में सुपरवाइज्ड लर्निंग का लेबल डेटा होता है, इनपुट आउटपुट पेयर्स होता है, और अनसुपरवाइज्ड लर्निंग में अनलेबल्ड डेटा होता है। जो फाइनल आउटकम या गोल हमें चाहिए फॉर सुपरवाइज्ड लर्निंग, इट इज टू प्रिडिक्ट आउटकम्स बेस्ड ऑन पास्ट डेटा. While in the case of unsupervised learning, it is to find hidden patterns or structures in the data. Some examples of algorithms of supervised learning is linear regression, decision trees, random forest, neural networks. While example of unsupervised learning are k-means clustering, PCA. If we see some use cases, then in supervised learning, spam detection, fraud detection, some stock price prediction, these are examples of supervised learning. Customer segmentation, market basket analysis, these are examples of unsupervised learning. Now the next question is, how do you handle missing data? When answering how do we handle missing data, use a structured approach that covers identification, analysis, and handling technique. For example, start with identification of missing data, how you identify missing values. We identify missing values using pandas isnal method, or we also identify missing values using visualization technique. So you can explain these methods. Then once identification is done, we need to analyze missing data. So explain how you can analyze missing data, like whether the missing data is random or it is not random. So explain those things. Third is how you can handle missing data. So there are different methods to handle missing data, like removing missing data, uh, dropping rows, dropping columns, imputing missing data, and in also the method of imputation, how you are imputing missing data, whether you are using mean, median, mode imputation, when to use mean, when to use median, when to use mode. Generally, we use mean for normal distribution, median if data is skewed, and mode for categorical data. Then there is another method, forward or backward field, which is used for time series data. So explain that as well. And then KNN imputation method is also there. So impute missing values using KNN method, regression method. So explain all these. Then choosing the right approach, how we can choose the right approach. So if missing data is very small, generally we drop the rows. And if the missing data is random and limited, we use either mean, median, or mode method to impute missing values. If missing data is time dependent, then we use forward or backward fill. And if missing data is complex and dependent on other variables, then we use KNN method or any regression method to impute the missing values. And what is the impact of handling missing data? It improves model accuracy by reducing bias. It prevents error in data processing. It also enhances data consistency for better decision. So you can also summarize in the end, like to handle missing data, we first identify and analyze the missing values. Depending on the situation, we either drop impute or impute by mean mode, or use advanced techniques like KNN or regression imputation. The right approach depends on the amount and nature of missing data to ensure data quality and model accuracy. So the next question is, explain overfitting and how to prevent it. When answering this question, again आपको वही structured approach use करना है, covering definition, causes, detection, and prevention techniques with examples. So, first is definition. What is overfitting? Overfitting happens when a machine learning models learn too much from training data, capturing noise instead of general pattern. This leads to high accuracy on training data but poor performance on unseen test data. We can take an example. Suppose we train a model to classify email as spam or not spam. If the model memorizes specific words from the training email instead of understanding the general pattern, it will fail on new emails. And what are the causes of overfitting? First is small data set. If the data set is very small, it can cause overfitting. Next is too complex model. If we use a very complex model, example, any uh, deep neural network with excessive layers, that can also cause overfitting. And the third cause is too many features. When unnecessary variables are used, it also causes overfitting. Once you have covered definition and causes, then come to detection. How to detect overfitting? High training accuracy but low test accuracy is the main criteria of overfitting. If there is large gap between training loss and validation loss. Also, cross validation results show inconsistent performance across folds. So these are the ways to detect overfitting. And how to prevent overfitting? So we can use database techniques like increasing training data, using data augmentation. Then we can use feature selection. We can use model based techniques like regularization, L1 and L2 regularization. Then we can use pruning for decision trees. Then we can use dropouts for neural networks. Then we can use training based techniques like cross validation, early stopping. So these are the ways through which we can prevent overfitting. In the end, like we can give a summary that overfitting happens when a model learns too much from the training data and fails on new data. It can be prevented using techniques like regularization, dropout, feature selection, and cross validation. And a well balanced model generalizes better and performs well in unseen data. So, the next question is, how do you evaluate the performance of a machine learning model? When answering this question, first start with why evaluation of model is needed. So, evaluating a model helps us to understand how well the model is performing, and it ensures that the model is neither underfitted or overfitted. Next, what are the performance metrics? So, it is usually based on problem type. So, if it is a classification model, example, prediction categories, spam prediction, or not spam prediction. So the key metrics will be accuracy, precision recall, then if and also we use F1 score if the model is regression model, where where we predict continuous values. For example, stock prices, there we use key metrics like mean absolute error, mean squared error, root mean squared error, r square. And for the model validation techniques, we use train test split, cross validation, then a confusion matrix for a classification model. So if the problem is overfitting, then we use regularization, dropouts, or we increase data. If the problem is underfitting, we use a more complex model, add features, increase training time. And if the problem is class imbalance, we use precision recall, F1 score, SMOT to adjust class weights. So these are the ways to handle model performance issues when identified according to the problems. So next question is, what is the bias variance trade-off? It is one of the most common question asked in every interview. तो इसको आंसर करने के लिए पहले दोनों को डिफाइन करना है, बायस और वेरिएंस को. What is bias? Bias refers to error introduced due to oversimplicity or over simplistic assumptions in the model. A high bias model does not capture patterns well, leading to underfitting. And what is variance? Variance refers to the model's sensitivity to small fluctuation in the training data. A high variance model learns noise along with the patterns, leading to overfitting. That is high training accuracy but poor test accuracy. Now, what is bias variance trade off? If a model has high bias, it is too simple, and if a model has high variance, it is too complex. So, the goal is to find a balance between bias and variance to achieve the best model. Example, if we take an example of predicting house prices, a linear regression model may assume all houses follow a simple trend and miss important details, which is a case of underfitting. If we use a deep neural network which has high variance, so it may learn noise in the training data and fail to generalize to new data. So if we use linear regression, then it will be a case of high bias. But if we use deep neural network, then it will be a case of high variance. So an optimal model finds a middle ground, capturing patterns without memorizing noise. So how we to reduce bias and variance? If the problem is that it has high bias, use a more complex model, example decision trees, neural networks, or and more relevant features. So in this case, the variance will increase a little bit, but the bias will reduce. Similarly, if the model is high variance, use a regularization, L1 L2 regularization, which will reduce model complexity and increase the training data. Apply a dropout method in neural networks, so it will reduce the variance but somehow it will increase a little bit of bias. So it is often represented as a U-shaped curve where test error is minimized at an optimal complexity level. So, bias variance trade off is the balance between underfitting and overfitting in the machine learning. High bias models are too simple and fail to capture patterns, while high variance models are too complex and capture noise. So, the goal is to find optimal balance between the techniques. Next question is, what is your approach to solve a business problem using data science? इस क्वेश्चन को आंसर करने के लिए स्टेप बाय स्टेप ब्रेक डाउन करना होगा। इसमें फर्स्ट स्टेप होगा अंडरस्टैंडिंग द बिजनेस प्रॉब्लम एंड डिफाइनिंग KPIs. Then second will be collecting and exploring relevant data. Third will be pre-processing and feature engineering. Fourth, selecting and training model. Fifth, evaluating performance. Sixth, deploying the model in production. Seven, measuring impact and redefining the model. This solution is data driven, effective, and aligned with business goal. So you can answer this question in this way. You can explain every step also, like what is there in understanding business problem, how you identify goal of the problem, how you discuss it with stakeholders, how you define KPIs, then what is data collection and exploration, how you identify relevant data sources, how data is collected, then in data pre-processing and feature engineering, what are the methods like handling missing data, feature engineering, data transformation, splitting data into train, test, split, what is the percentage used in train, test, split, then model selection, depending upon the problem which model should be chosen, like classification, regression, clustering. Based on the problem, you can choose the model accordingly. Then model evaluation and optimization. Using the right evaluation model, right evaluation method is very important. So you can explain that as well. Then model deployment, how model can be deployed, what are the methods to deploy the model. Then measuring impact and continuous improvement, so how pre-model and post-model business performance is compared. uh, so this is the method or to answer this question. Next question is, what is the difference between bagging and boosting? So bagging and boosting both are ensemble methods used to improve model performance. When answering this question, पहले बैगिंग डिफाइन करना है, फिर बूस्टिंग डिफाइन करना है, और फिर दोनों के डिफरेंसेस बताने हैं. Bagging trains multiple models independently on different random subset of data, and the final prediction is made by average if it is a case of regression, or majority vote if it is a case of classification. And what is the goal of bagging? It reduces variance and prevent overfitting. For example, random forest, a collection of decision trees, are trained on different random subset of data. That is a case of bagging. Then, what are the key characteristics? First is parallel training. Models are trained independently. Also, you can take it as parallel training. Then, reduces overfitting. Then, works well with high variance models like decision trees. And when to use bagging? When the model overfits and needs variance reduction. Next is boosting. Boosting trains models sequentially, where each model learns from the errors of the previous one. Models were weighted, giving more focus to misclassified points. What is the goal? It reduces bias and improve weak learners. Example are ADA boost, gradient boosting, XGBoost, light GBM. These are examples of boosting. What are the key characteristics of boosting? First one is sequential training. Each model corrects previous mistake, then it reduces bias, and it is more prone to overfitting if not tuned properly. And when to use boosting? When the model underfits and needs bias reduction. So, major differences between bagging and boosting is in training type. In bagging, it is parallel training type, and in boosting, it is sequential training type. And goal of bagging is it reduces variance and prevents overfitting, while boosting reduces bias and improve weak learners. For data sampling in bagging, it is random subsets bootstrap, while in boosting, it is full data set but weights adjusted for misclassified samples. Model weights in bagging, it is equal weight to all model, while in the case of boosting, it is in higher weights to better model. Risk of overfitting is low in bagging, while it is higher in boosting. Examples of bagging are random forest and bagging classifier. Examples of boosting are AdaBoost, gradient boosting. Next question is, how do you handle multicollinearity in a dataset? So, what is multicollinearity? It occurs when two or more independent variables are highly correlated in a dataset. And this can lead to unstable coefficients in regression model, difficulty in interpreting feature importance, overfitting due to redundancy in information. And what are the methods to handle it? First one is calculate variance inflation factor, which is VIF. VIF quantifies how much the variance of a regression coefficient is inflated due to multicollinearity. If, for example, if VIF is greater than 5 or 10, the variable is highly correlated. And what is the solution for this? Drop variables with high VIF or use techniques like PCA. Now, next is remove one of the highly correlated features. So, compute the correlation matrix and drop one of the correlated variables. It is best when features provide similar information. Third one is using PCA. PCA is Principal Component Analysis. PCA transforms correlated features into uncorrelated principal components. It retains most important information while reducing dimension, and it is useful for reducing multicollinearity in high dimensional data set. Next method is use regularization, either L1 or L2 regularization. So, if the data set is small and have new features, drop highly correlated features. If data set is high dimensional data set, then use PCA. If in case of linear regression problems, use VIF to detect and then drop or use L1, L2. And for model interpretation is important, the cases where model interpretation is important, use lasso regression. Next question is, how do you stay updated with data science trends? इस क्वेश्चन का आंसर बहुत स्ट्रॉन्ग आंसर होना चाहिए, which should demonstrate proactiveness, continuous learning mindset and practical engagement. तो इसके लिए you should mention that you are reading research papers and blogs. Mention some research papers and some blogs which are famous and which provides good information. Then online courses and certification. You should take some online courses and certifications which you can mention in the interview, that I have taken this online courses, from Udemy or Coursera, whatever the platform you have taken the courses from. Then how you engage with a data science community, whether on LinkedIn, on meetups, on webinars. So you can mention that. Then hands-on project is very important for answering this question. How many hands-on projects you have prepared? Explain any one project which is aligning to latest data science trends. Then how you experiment with new tools and technologies, explain those. So your answer should be structured, and it should be proactive, and you must mention the hands-on and experiments which you have done. Thank you so much for watching this video. If you have any doubt, any question, or any suggestion, please let me know in the comment section. And if you like this video, please do like and subscribe. Thank you.